Now, President Biden has introduced the first image to be shown publicly from the James Webb Telescope, the largest and most powerful ever launched into space.
A new space telescope, described as one of the greatest scientific endeavours of the 21st century, is on track to launch next month. Scientists hope the James Webb Space Telescope.
At first, the discovery seemed like a glitch. The telescope's sensors recorded gravitational ripples emanating from a sector of dark void. Empty void where nothing should be. But as researchers cross-checked instruments and recalibrated mirrors, checks turned into confirmations. What lay at the heart of that void was a massive anomaly. Something, or something's effect, spanning light years of seemingly nothingness, warping space-time in a pattern unlike any seen before. That invisible presence sent ripples through cosmic background radiation, through stellar orbits, through the delicate gravitational dance of galaxies. It was a disturbance of such scale that it suggested an ancient cosmic entity, or a natural force so powerful it had simply gone unnoticed until now. Before we start, smash the like and subscribe buttons for more updates. This was not a black hole, not exactly. It had no visible event horizon, no accretion disk glowing with X-rays or jets. Yet stars sung around it, light curved strangely, cosmic microwave readings shifted ever so subtly. The world felt that chill, that frenetic excitement, because what the telescope had uncovered was not a star or planet, but a void with purpose, a cosmic anomaly that acted like an architect of space, bending and shaping reality itself. People across continents suddenly realized, there are forces in the universe that defy even the boldest human imagination. Scientists rushed to analyze the data. Teams pored over spreadsheets and debated in observatories barely illuminated by red lights. The implications were staggering. If such an entity existed, invisible yet immense, it meant the universe held dynamics entirely outside our theoretical frameworks. The Standard Model, Einstein's equations, quantum theories, they might all be incomplete. This wasn't a failure by those theories in small increments. This was a rupture. A hum of unease crept into public consciousness. TV pundits tried to explain it with shaky confidence. But the next wave of science communicators urged deeper clarity. The term cosmic anomaly was coined in headlines, but its meaning was nebulous, even if it didn't pose an immediate danger. The idea that a silent architect of gravity lurked in the firmament unsettled millions. Our place in cosmic stability, our confidence that the universe was comprehensible, and by extension safe, was undermined in one brilliant probe of infrared light. It was clear that the James Webb Space Telescope had done more than peer into the ancient past. It had opened a doorway into a present reality of unseen powers. And those powers felt cold, unfeeling, unknowable, perhaps indifferent. Icy fear gripped us, not because anything moved to threaten Earth, but because nothing moved, yet commanded might. The realization settled into our collective psyche that lurking in the voids could be invisible forces that shaped the paths of stars and galaxies, and none of our ancestors had ever seen them. Astronomers and physicists scrambled to devise new theories. Some posited that the anomaly might be a manifestation of non-baryonic matter, unlike dark matter, something even more exotic, a variable gravitational void. Others speculated it was a remnant of conditions before the Big Bang, a relic of cosmic inflation embedded in the fabric of space-time. If true, then our cosmological timeline needed rewriting. The infrastructure of everything from particle physics labs to cosmology journals would have to pivot. Universities might reassign chairs, researchers shift focus for decades. Beyond the academic sphere, a cultural moment emerged. Poets found themselves grappling with the emptiness behind the veil of stars. Filmmakers envisioned cosmic statues of invisible power sculpting galaxies. Philosophers speculated whether such purposeless yet architectural forces implied a deeper metaphysical order, or none at all. Had the universe built itself with hidden scaffolding? Was free will itself as insubstantial as that architecture? People who'd never glanced at constellations before began staring up, searching for hints of the anomaly, even though it was undetectable to the naked eye. That sparkle among Orion's belt? Could that be where it lurked? Could our view of the night sky betray spaces running with unseen currents of cosmic control? It was too alluring to resist that shiver of wonder. Journalists interviewed astrophysicists who spoke of portals of gravitational aberration and architectural voids, but their words landed heavy and cryptic. Science fiction authors seized upon the concept immediately, weaving stories of civilizations discovering and perhaps harnessing these voids. Could an advanced species have learned to steer galaxies along these invisible channels? The implications for interstellar travel, for manipulating the structure of the cosmos, for things we cannot yet imagine, suddenly had credible roots. The world froze not from dread of annihilation, but from exhilaration at cosmic mystery. The notion of control itself felt trivial in the face of unseen voids guiding the motion of entire clusters. We became small in a way that was intimate, dwarfed not by brutality, but by subtlety. The next steps in the search were vigorously mapped. Telescopes around the globe reoriented, space missions drafted contingency plans, mathematicians raced to model these voids, and across all of it the hum remained, a cold reminder that discovery is not always warm. Letters streamed to science museums, requests for public lectures, drawings of galaxies twisted around nothingness, metaphors of fate and emptiness. Teachers tried to find words for children. A giant invisible curve in space, some said. Something made of silence, others wrote, and everywhere the phrase terrifying discovery took on new meaning. It wasn't an object launching cosmic death rays, it was an absence powerful enough to command how stars dance. The James Webb Space Telescope's discovery resonated with political thinkers too. Government committees convened to fund more deep space missions to investigate whether this anomaly hinted at physics that could revolutionize propulsion or energy. Could that void be harnessed? Could humanity learn to slide along warp currents? The cost of orbiting observatories soared, but budgets shifted as fear of ignorance converted into investment. We felt the world had frozen in the glare of that revelation, as if contemplating whether to run toward or away from the abyss. Communities of amateur skywatchers formed digital networks, sharing images and theories, though official representation remained elusive. Astrovoid hashtags appeared on social platforms, mixing awe with the question, are we even safe knowing this? It was a different kind of dread, celestial in origin, philosophical in tenor. We felt exposed not by proximity but by knowledge. The unseen forces were not coming for us, but we had come for them. And now, on a cold fringe of understanding, we stood frozen between knowing and not. As the world turned, scientists pushed the boundaries of detection, seeking similar anomalies. If this wasn't unique, then such void architects might be countless, weaving through the cosmic tapestry. That would mean the universe was riddled with invisible structures shaping both the macro and micro. Could planets, life, cosmic filaments all be aligned by these curvatures? Were we living atop one of their ridges? The implications for everything from cosmological principle to anthropic reasoning were profound. The discovery seeped into popular discourse, late-night conversations, podcast guests speculating whether consciousness might interact with these voids unintentionally. Was reality layered atop unseen frames? Artists began exploring invisible structures in galleries using empty space to evoke form. The public imagination expanded, no longer thinking of emptiness as absence but as presence. Potent, sculptural, architected. Meanwhile, theoretical physicists attempted to anchor the phenomenon mathematically. If it were some higher dimensional effect leaking into our algebra, then string theories might offer clues. If it were quantum geometry, loop gravity might speak. The race was on to tie what Eliot had called invisible pillars into the scaffold of physics. Meanwhile, the world watched, fascinated by both the cosmos and our attempts to translate that cold revelation into meaning. That chill, reminding us humanity stood at the edge of comprehension, did not dissipate. If knowledge is power, then this anomaly was an unknown power, invisible and vast. Scientists compared notes, modeled everything from gravitational lensing to vacuum fluctuations. Engineers designed proposals for future telescopes fine-tuned to survey emptiness. Policymakers debated whether this merited redeployment of resources. Everyone felt it. The world paused, waiting to see whether understanding would thaw the unknown or reveal deeper frost. And as the revelations continued, contrast maps, simulations, speculative frameworks, it grew clear. The terror wasn't in what we had discovered, but in the realization that discovery was only revealing the surface. The universe was stranger, colder, more beautifully inscrutable than we'd ever dared imagine. The James Webb Space Telescope had not just looked farther than before. It had uncovered that even the voids can speak, and what they said was beyond our vocabulary. That voice, carried across eons in infrared light, left us frozen not in fear, but in wonder. We realized that we must learn new languages of emptiness, new grammars of curvature. Our place in the cosmos suddenly felt simultaneous, tiny and central, humble and hopeful. The void held power, but so did our curiosity, and though the world froze at first in awe and confusion, it began to pulse again, ready to explore what lies beyond the visible, reaching toward understanding in the chilly light of the unknown. The search did not pause after the initial confirmation of the anomaly. The James Webb Space Telescope's operators began fine-tuning its infrared instruments to probe the phenomenon at multiple wavelengths, peeling back layer after layer of electromagnetic data that revealed a story both haunting and profound. Every shift in the spectral output, every minute distortion in the paths of background galaxies, painted a more intricate portrait of the invisible presence. It was not uniform. It pulsed with faint periodic patterns, subtle enough that they had evaded detection by less sensitive instruments for decades. That rhythmic fluctuation hinted at a dynamic process, something moving, breathing, perhaps even evolving on a scale that dwarfed human comprehension. The anomaly became a living puzzle for astrophysicists. While the public imagined a dark, silent edifice in space, the research community began to see it as an active player in the cosmic arena. Data analysis teams at space agencies worldwide detected gravitational lensing effects that shifted over time, as though the unseen structure were flexing its grip on the surrounding space. That revelation deepened the mystery. If it could change, then it was not a relic frozen since the dawn of time. It was a present tense force, interacting with the universe in ways no current theory could fully articulate. This forced scientists to reconsider fundamental assumptions about the way cosmic structures form and decay. Normally, immense gravitational distortions are tied to visible mass: stars, gas clouds, galactic cores. Here, no such mass was present. The Webb's high-resolution imaging confirmed the absence of any luminous counterpart. The energy signature, such as it was, resembled neither matter nor conventional dark matter. Instead, it resembled a form of gravitational imprint, a three-dimensional scar in spacetime, persisting without an obvious cause. The possibility emerged that these anomalies might be scars from collisions between universes or regions of reality during early cosmological epochs, moments when the laws of physics themselves were malleable. The world followed every update with rapt attention. The discovery had ignited a fascination that transcended national borders, language barriers, and cultural divides. It was one of those rare cosmic moments that reminded everyone that our planet is a shared cradle floating in a vast, uncharted sea. News segments dedicated entire evenings to visual simulations of the void. Animations reconstructed the slow bending of light, the unseen mass's influence spreading like ripples through the cosmic pond. Viewers watched as galaxies warped into arcs around the emptiness, their beauty made unsettling by the knowledge that the artist was invisible. This sense of invisibility became the emotional core of the public's fascination. The anomaly was not simply out there. It became a metaphor for all the forces in life that shape outcomes without ever revealing themselves directly. People began to relate to it in strange ways, seeing in its quiet manipulation a reflection of unseen influences on their own lives. Social discourse shifted toward contemplating hidden systems, whether in nature, society, or the human mind. The scientific discovery had planted seeds far beyond the observatories. The scientific implications only grew more staggering as the Webb's continuous observation campaigns expanded. The telescope tracked subtle changes in the cosmic microwave background near the anomaly, faint ripples suggesting that it might be interacting with the universe's oldest light. If confirmed, this would mean that the phenomenon was not only shaping galaxies, but was in dialogue with the remnants of the Big Bang itself. That sort of interaction had never been observed before. It hinted that the anomaly might play a role in regulating or distorting the cosmic background over immense spans of time, perhaps subtly influencing the conditions for matter to coalesce. Such a possibility drew in cosmologists who had long debated whether the universe's structure was truly random, or whether hidden frameworks guided its evolution. The discovery gave credence to the idea that there could be large-scale organizing forces baked into the fabric of reality, forces that act invisibly but leave unmistakable fingerprints when observed with the right tools. This was a seismic shift in thinking. Entire careers were now being built around understanding a single unseen entity millions of light years away. As these revelations trickled into public awareness, the emotional texture of the world's response began to change. The initial freezing awe gave way to a sharper, more inquisitive edge. If this anomaly existed, could there be others closer to home? Could similar distortions lurk in our own galaxy, perhaps even in the regions between the spiral arms of the Milky Way? Space agencies began drafting observation schedules to survey nearby sectors of space with unprecedented precision. Ground-based observatories in Chile and Hawaii joined the hunt, their adaptive optics fine-tuned to detect even the faintest gravitational aberrations. The global scientific community transformed into a network of coordinated observers, each station taking turns to track the anomaly as Earth rotated, ensuring that the data stream remained continuous. This level of collaboration between rival agencies was rare, and it was a testament to how momentous the Webb's discovery truly was. In private, some scientists confessed that they had the feeling of standing on the shoreline of an immense ocean, just beginning to understand that waves were crashing far beyond their line of sight. While astrophysicists refined their measurements, theorists turned to mathematics for guidance. New models emerged that treated space-time not as a passive stage, but as a living medium, capable of retaining the echoes of ancient events like a drumhead holding vibrations. In such models, the anomaly could be seen as a standing wave of gravitational energy, anchored to no mass yet exerting influence over everything in its vicinity. These theories ventured into exotic territory, suggesting that the universe might store information about its earliest moments in patterns we are only now learning to decode. The Webb's instruments also detected faint emissions in the far infrared spectrum near the anomaly. These emissions were not consistent with known astrophysical processes, leading to speculation that they might be byproducts of whatever mechanism maintained the anomaly's gravitational influence. The idea that the void might be generating or leaking energy into its surroundings stirred debates about energy conservation on cosmic scales. If such phenomena could create usable energy, even theoretically, it would rewrite the boundaries of astrophysical engineering. The fascination deepened when simulations revealed that removing the anomaly from its sector of the universe would radically alter the motion of surrounding galaxies. It was as though this invisible entity served as a hidden counterweight, preventing the collapse or dispersal of an entire galactic neighborhood. That realization reframed the anomaly not as a passive oddity, but as a keystone in the cosmic architecture. Without it, entire swaths of the universe might look drastically different, or perhaps not exist at all in their current form. The philosophical ramifications of that insight reverberated across disciplines. If the universe required such invisible stabilizers to maintain its structure, then perhaps existence itself was more precarious than previously assumed. The notion of a delicately balanced cosmos, its stability hinging on silent, unseen forces, made the anomaly feel less like an isolated curiosity and more like a revelation about the true nature of reality. As the Webb continued to observe, its instruments began mapping the three-dimensional curvature of space around the anomaly with exquisite detail. The pattern suggested that its influence extended far beyond what was initially measured, possibly linking it to other gravitational features across vast distances. This raised the possibility that the anomaly was part of an interconnected network of similar structures, a cosmic web hidden beneath the visible one. If true, the universe was more like a layered construct, with invisible scaffolding guiding the placement and motion of all visible matter. The idea of a hidden cosmic infrastructure ignited the imagination of engineers and futurists. If such structures could be charted, then navigation through deep space might one day exploit these gravitational corridors, much like ancient sailors followed ocean currents. The difference was that these currents would be invisible to all but the most sophisticated instruments, their presence detectable only through the subtlest bending of starlight. The promise of this knowledge lay in its potential to transform space exploration into something faster and more efficient than ever conceived. In the midst of this excitement, Cultural reactions flourished. Artists began integrating representations of the anomaly into sculpture and digital media, capturing its paradoxical nature, something vast yet invisible, influential yet untouchable. Musicians composed pieces structured around subtle, repeating themes to evoke its rhythmic gravitational pulses. Writers conjured entire genres of cosmic mystery, blending scientific realism with the awe of encountering forces that operate outside human perception. In schools and universities, the discovery became a case study in the evolving nature of science. Students were shown how a single observation could ripple through every branch of knowledge, inspiring not just technological innovation, but a shift in how humanity defines its place in the universe. Lectures highlighted the way the Webb's advanced instruments had allowed us to detect the undetectable, underscoring the value of curiosity-driven exploration. The anomaly's sheer distance from Earth provided a strange kind of comfort. It was remote enough that it posed no direct threat, yet close enough in the cosmic sense to remind us that our neighborhood is part of a much larger and more mysterious whole. This balance between safety and wonder kept public interest alive, driving demand for updates and new imagery from the telescope. Meanwhile, computational models became more sophisticated, using machine learning to predict how the anomaly's influence might evolve over the next billion years. These simulations hinted at gradual shifts in its gravitational field, suggesting that whatever sustained it might be subject to change. This led to speculation that the anomaly could eventually dissipate, leaving behind a dramatically altered cosmic landscape. For now, though, it stood as a monument to the unseen forces that govern the dance of galaxies. In time, the anomaly came to represent more than just a scientific breakthrough. It became a symbol of the unseen dimensions of existence, a reminder that reality is layered with complexities that lie far beyond the reach of our senses. The James Webb Space Telescope had not only expanded our view of the universe, it had deepened our sense of mystery, revealing that even in the emptiest stretches of space, there are wonders powerful enough to shape the cosmos itself. The James Webb Space Telescope's relentless observation of the anomaly soon began to illuminate aspects that no one had predicted. While the original data had captured its gravitational influence and its distortion of background light, further analysis uncovered something far stranger: microscopic variations in its spatial curvature that changed over time, almost like a slow, deliberate modulation. This was not simply a fixed dent in the fabric of the cosmos. It appeared to be adapting, reconfiguring itself in ways no known physical law would require. The behavior defied the expectations of even the most speculative models. High-resolution interferometry from both Webb and coordinated Earth-based telescopes revealed that these minute fluctuations were synchronized with distant cosmic phenomena, gamma-ray bursts, pulsar emissions, and shifts in the magnetic fields of far-off galaxies. The implication was staggering. The anomaly might not be isolated at all. It could be part of a networked system, connected across incomprehensible distances, reacting to events light years away almost in real time. Such synchronicity hinted at an underlying medium or mechanism faster than light itself, a notion that would rewrite the bedrock of relativity. As the research deepened, astrophysicists proposed the radical idea that the anomaly might function as a kind of cosmic relay, transmitting influences or information along invisible pathways. If true, it could be a manifestation of the universe's own communication system, one that had operated unnoticed for billions of years. This forced scientists to think beyond gravitational effects and consider what role such a system might play in the life cycle of galaxies, or even in the distribution of matter and energy throughout space. The search for evidence extended into regions of the electromagnetic spectrum rarely associated with large-scale cosmic structures. Specialized detectors scanned for faint neutrino emissions and high-energy particles, hoping to detect some kind of signal that could explain the anomaly's responsiveness. To everyone's surprise, background neutrino levels around the anomaly's position did show subtle statistical deviations. Though faint and still poorly understood, these fluctuations suggested the anomaly might be interacting with particles that barely interact with matter at all, potentially using them as a medium for whatever process sustained it. This opened up an entirely new frontier of study, the intersection of astrophysics with particle physics on a scale that made laboratory experiments seem miniature by comparison. Researchers began to speculate that these void-like structures could act as interdimensional boundaries or conduits, allowing phenomena from other realms of existence to seep into our universe in a controlled fashion. While such speculation was met with skepticism in formal publications, the private discussions among leading physicists revealed just how far the Webb's discovery had pushed the boundaries of conventional thinking. One of the most remarkable developments came from mapping the region around the anomaly in unprecedented detail. Using gravitational lensing data, scientists reconstructed a kind of three-dimensional topography of the surrounding spacetime. Instead of being smooth or uniformly curved, the region displayed intricate wave-like ridges and troughs, as though the anomaly's gravitational field were sculpting space into a patterned geometry. These patterns bore mathematical similarities to certain quantum wave functions, sparking theories that the anomaly could be a macroscopic manifestation of quantum processes, an enormous stable wave structure bridging the gap between the subatomic and cosmic scales. The discovery of these patterns had profound philosophical consequences. If structures like this could emerge from the fundamental quantum fabric of reality, then perhaps the universe's vast complexity was not just the result of chaotic processes over time, but the expression of deeper mathematical harmonies. The anomaly could be evidence of a unifying principle that wove the laws of the very small and the very large into a single coherent framework. Beyond theory, practical implications began to surface. Engineers and technologists speculated about whether the anomaly's geometry could be modeled and replicated in controlled environments. Even partial replication might allow the creation of regions of altered gravity or time flow, which could revolutionize propulsion systems and space travel. Such speculation remained distant from practical reality, but history had shown that scientific breakthroughs often began as dreams sparked by phenomena once thought impossible to reach or control. Meanwhile, sociological ripples spread across the globe. The anomaly, remote and untouchable though it was, became a rallying point for international cooperation in science. Nations that had long guarded their astronomical data began sharing observations freely, recognizing that the magnitude of the discovery transcended geopolitical rivalries. Collaborative observation campaigns linked space agencies, universities, and independent research groups into an unprecedented web of knowledge sharing, echoing the very connectivity that the anomaly itself seemed to exhibit. Religious and spiritual communities also engaged deeply with the news. Some saw in the anomaly a form of cosmic order, a signature of intelligent design written not in matter but in the invisible skeleton of the universe. Others embraced it as a symbol of humility, a reminder that human beings were still at the dawn of understanding the true nature of existence. In this way, the scientific discovery wove itself into cultural narratives as profoundly as any myth or legend. As the Webb continued to stream data, new anomalies began to appear, not as massive or pronounced, but bearing enough similarity to suggest they belonged to the same category. This was a turning point. It meant the original discovery was not a singular oddity, but part of a larger population of hidden cosmic architectures. These smaller structures were scattered throughout deep space, their gravitational signatures faint but unmistakable. Suddenly, the universe looked far more structured beneath the surface than anyone had imagined. Computer simulations incorporating these new data sets showed how such anomalies could form an invisible scaffold for cosmic evolution. Galaxies appeared to cluster and align along pathways subtly shaped by the hidden network, as though the visible universe were draped over a framework of gravitational currents. If these currents could be mapped with precision, humanity might gain the first true navigational chart of deep space, one drawn not by visible landmarks but by the invisible architecture that had guided cosmic motion since time immemorial. Such a chart would be invaluable for future exploration. Spacecraft could potentially travel vast distances more efficiently by falling along the gradients created by these anomalies, conserving fuel and time. This concept, dubbed gravitational drift navigation, became a serious topic of research in aerospace engineering circles. While practical implementation remained far off, the theoretical groundwork was being laid, all sparked by a single, silent discovery millions of light years away. Even as the scientific possibilities expanded, the anomaly retained its aura of mystery. Observations continued to defy neat categorization, In some recordings, faint flickers of infrared emission seem to pulse in irregular sequences, almost like a code. Attempts to decode these patterns yielded no coherent message, yet the very act of looking for meaning reflected a deeper human impulse to interpret the unknown as communication, whether the anomaly was saying anything or not. Its presence invited humanity to listen harder to the cosmos. As months passed, the Webb's mission logs became a tapestry of incremental revelations. Each new dataset added a brushstroke to the growing portrait of an invisible force that shaped galaxies, echoed across light years, and hinted at dimensions of reality that had until now remained closed to us. And with each edition, the sense grew stronger that we were standing at the threshold of a new era in astronomy. The universe had opened a door, not to a place but to a way of perceiving, one in which the empty spaces were as alive with meaning and structure as the stars themselves. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on JWST's terrifying new space discovery? We want to hear from you. Thank you for watching, and see you next time.